All right, welcome to today's lesson. So first of all, let's get a little bit of bell work going. We've got three problems here that should look familiar. The first one says solve for y, but in slope-intercept form. The second one says find the slope. And the third one just says solve this multi-step equation. So I went ahead and got these all started off with the first step listed here, and now we'll kind of finish them off. So the first one, we moved 3x to the other side, and now all we have to do is divide by the 4 that's left in front of y. And when we divide by 4, we will have an equation written in slope-intercept form. So it'll be y equals -3/4 x, and then 16 divided by 4 is 4, so -4. So that's slope-intercept form, the slope being -3/4 and the y-intercept being -4. And this type of an equation is going to become very important this week because we're going to use it quite a bit. The next one, find the slope. So we do y1 minus y2, so -2 minus 6, which equals -8. Then we did x1 minus x2, which is 4 minus -1, which just is a +5. So the slope of a line between those 2 points is -8/5. Pretty steep slope. Okay, on this next one, we're going to solve this equation. And so in order to do it, we have to start with a distributing property. So 3 times 3w would be 9w. 3 times -1 is -3. And then 12 times w is 12w. And 12 times 4 is 48. All right, so now all we have to do is move the variables to one side and the numbers to the other. And I'm going to minus 9w from both sides to kind of keep things positive, because if I minus 9w from that 12w, I'll stay positive. So that leaves me with -3 equals, and then I have 3w plus 48. So my next step is going to be subtract 48 from both sides to move 48 to the left side. And so I need to extend that page one more time so I have plenty of room here. So when I subtract 48, I end up with -51 equals 3w. So when I divide by 3, -51 divided by 3 is -17, and that equals w. So that's my answer for question number 3. So they take a little bit of work, but it's all right, because life sometimes has some more complicated questions that we need to get to, and being ready to go is what we need to do. All right, so you're going to watch this video. It's about functions. It might be a little startling at first because it's talking about where do chicken sticks come and fish sticks come from and all those kinds of things like in meat processing, but it ties it to a mathematical thing that we call functions. So watch that video real quick, and then we'll see you on the next page. So we're talking about a function. So what is a function? Well, a function is a relationship that pairs each input with exactly one output. So basically, you've got this little mathematical function or equation, or you've got a machine or something you can put stuff into, and it transforms it into something else, and out it comes. So in the case of an equation like this, you put in an x value and out comes a y value. So it's just transforming numbers or describing the relationship between two sets of numbers. Okay, so what do we mean by input, output, domain, and range? Well, for linear functions, which we've been learning about this year, the values that you put in the function are the x values. And that's why we solve them for y, so that you can put in those x values and get a logical output. The output values are what comes out of that equation or function, and those are what we call the y values. Now there's a couple more names that we give these numbers. So all the set of all the input or x values that you input into a function is called the function's domain. All right, so now if you look at all the output values that come out of that same function after you put in the domain values, the values that come out are called the range. These are all the y values, the set of all the y values. So you could put in one x value and get out one y value, but when you put in a bunch of them, then we call those sets the domain and the range. So kind of keep these words in the back of your mind. All right, so also when we're talking about a function, and again, we're talking about equations that are written like this: y equals some number times x plus or minus some other number at the end. When it's written like this, it's in function form, and there's the two variables. We have x and y, and the variable, the thing that represents the input values, is the x value. That's usually the independent variable, which means we can choose what we put in for x. We can put in a 0, we can put in a 1, we can put in a 2, or whatever we want. But once we choose an x value, that will determine what is going to come out for y, because the function will do its thing and multiply that number or divide that number or whatever it does to that number. And so the y values that come out are called the dependent variable, and it depends on x. So functions can be described in many ways. It can be described by an equation, by an input-output table. It can be described in words. It can be illustrated on a graph. It can also be shown as a set of ordered pairs, a bunch of x and y values that go together in a set. So we're going to practice just working with these definitions for now and help you understand how they apply. So the first question, we give you a graph with 4 dots on it. So basically we have 4 input-output values there. And we want to know what's the domain and what's the range. Well, I'm going to write the coordinates of each point. So the first one is -1 and 0. The second point is 0, 2. The third point is 1, 4. And the last point is 2, 6. All right, so if we look closely, we realize that these are the x's, and these numbers over here are the y's, right? And if you remember from our definition just a few moments ago, the domain is the set of all the x values. So this is the domain over here, all these x values. So to list the domain, you just make a little set notation. And all your x values are -1, 0, 1, and 2. Okay, and now the y values that you see here are the output values, or what we call the range. So the range then is just the set of all the y values that are result from putting those x values into our function. So this range, or this set of y values, is 0, 2, 4, and 6. So those are the individual output values that we got from the 4 inputs, -1, 0, 1, and 2. Okay, so now we've got a little equation written in slope-intercept form, or what we call function form now. And so we're going to plug in some numbers and find some inputs and find out what our outputs are. So if we input 0, so 2 times 0 minus 4, so we're putting 0 in. 2 times 0, 0, 0 minus 4 equals -4. So my output is going to be -4. If I put in 3, 2 times 3 minus 4, so that's going to be 6 minus 4, which is 2. If I put in the number 6, 2 times 6 minus 4, 2 times 6 is 12. 12 minus 4 is 8. So that would be an 8. And the last one, 2 times 9 minus 4. 2 times 9 is 18. 18 minus 4 is 14. So now it says, what is the domain and the range? Well, this is the domain. So you just list all those numbers that we just found. And then these numbers down here are called the range. So the domain and the range, there you go. So that's all we're looking for in these kind of problems. Okay, now on Alex, you're going to see problems like this. The number of girls and boys in a committee is represented by the equation x plus y equals 6. The table shows the number of girls and boys. So we're going to write the equation in function form. So first of all, we got to solve for y in this function. So that means x is going to get moved over, and we're going to get y equals -1x plus 6. So that's the equation in function form. Now it says, what is the domain and the range? Well, we've been given a domain and a range up here. So the domain, if we put it in a set form, would just be 0, 2, 4, and 6. And then the range is just the numbers that come out of it as a result of this function. And that would be the y values. So that would be 6, 4, 2, and 0. So that is the range. Okay, how many people are on the committee? Well, it says right here there's going to be 6 people on the committee, so 6. Why is 8 not in the range of the function? Well, the range is a representation of our totals, right? How many people we can have. And 8 would be outside of that value. We can only have 6 people, right, on this committee. 6 total people. So that's why 8 can't be on there, because it would take us above that total of 6. What is the independent variable? So the independent variable in our situation here is x. And the dependent variable is y. So independent means we could have anywhere from 0 to 4 or 6 girls, and then the dependent variable would represent, we could have 6, 4, 2, or 0 boys, depending on how many girls that we started with. So that's how that works. So we're going to have you do the next problem on the back of your notes, on these guided notes. So flip that over and do that problem. And it looks like this. Joe spends $15 each time he travels on the toll roads. He started the month with $21 in the toll road account. Then after the amount A in dollars that he was left in the account after T trips to the toll road is given by the following function. Now that's still in function form. Let's just write that out so that it might be a little more familiar to you. So it would be minus 15t plus 210. So that's the y equals mx plus b form. So how much money does Joe have in the account left after 9 trips on the road? So all we have to do is go negative 15 times 9 and add 210 to that. So negative 15, if you got your calculator, get it handy. So negative 15 times 9 is negative 135. So negative 135 plus 210. So negative 135 plus 210 equals 75. So you would have $75 left after that many times. How many trips on the toll road can he take until his account is empty? Okay, so what we're going to look at is this function here, and we're going to say, when will the amount that he has left on his card be equal to 0? And then we write out our equation. That's a t plus 210. So all we have to do is subtract 210 from both sides. And then we subtract that number to find out what we have left over. So we end up with negative 210 on the left side equals negative 15f on the right side. And then we're going to divide by negative 15. And there we go. So negative 210, well, yeah, so 210 divided by 15. So it gives us 14, so it can make 14 trips. So that's how you would complete that equation on Alex, and you might need a little bit of workspace to show your work. Okay, so our assignment on this go around is called number 26, Introduction to Functions. So good luck with that and have fun.